Okay, now what we have here are some quadratic expressions, okay, and what I'm going to do in this video is I'm going to be factorizing them. So we need to learn how to factorize these because that has many uses later on. This is one that we should know already, and we should know what that would factorize to. And by factorizing, what I mean is I'm going to be rewriting this expression. So I'm going to write an equivalent expression to it, and that equivalent expression would be written as a product of some factors, and these factors can be some algebraic expressions like they will be here. Okay, and we know this one. We have to think about two numbers that multiply to give me negative 28, and if I was to add them I will get 3. Okay, and that's how I know what I will have in my brackets. And I also know that this will factorize to two brackets like this, with an x here and an x here. Now my two numbers will be 7 or positive 7 and negative 4. Okay, so positive 7 and negative 4, and I can write them here, negative 4. Okay, and I know that if I was to multiply this out I will get this. Okay, so I've rewritten an equivalent expression. That's why I've used the identity symbol. This is true for any value of x. I've just rewritten this. Okay, so I haven't made an equation or anything like that. So x times x is x squared. X times negative 4 will give me negative 4x. Add to that 7x, because that will give me 7x, and that will give me my 3x. And this 7 times a negative 4 will give me negative 28. Okay, and we should all be comfortable that this is the correct factorization for this. So what I've now done is, this is now a multiplication of what's in this bracket multiplied by what's in this bracket. Okay, and these are linear factors of this expression. Okay, now when we get to expressions like this where the coefficient of x squared is not 1, so here the coefficient of x squared we could have said is 1. Here it's not 1, and for this one as well. This method that we use to do this one doesn't work anymore. Okay, so we need to think about a different way to do that. So I'm just going to rewrite this one here, and we're going to work with this one. So what do we need to do? We have to, this is the method. Okay, so it won't seem very intuitive at the moment, but I'll show you something at the end of the video that you can watch if you want to, but I don't think you need to. You just need to be able to do this. You just need to be able to factorize this. But I'll show you something that might help you make sense of this. Okay, so what we do is the general form of a quadratic expression we can say is can be written as ax squared plus bx plus c. Okay, so that's just a general way to write a quadratic expression. And for this method, what we need to do is we need to do 2 times 3, and in this case it would have been a times c. Okay, so a times c we need to do, and we need to know what that is. And what I'm going to do is I'm just going to write it in a different color. So 2 times 3 will give me 6. Now this is the number that I used instead of the negative 28 here. So here we said two numbers that multiply to give me negative 28 and add together to give me this positive 3. Okay, so what you do for these ones is, instead of using numbers that multiply to give you 3 and add together to give you 7, you use numbers that multiply to give you 6 and add together to give you 7. Okay, so that's what we're trying to think about at the moment. So what will those numbers be? Let me just write this down slightly differently. So if I said there's a number here, and if I times it to something, a different number, so these are two different numbers in my boxes, I will get 6. And if I was to have the same number, so this number is the same as that one, and if I add it to this number is the same as this one, it should give me 7. Okay, so what numbers will they be? I know it's not going to be 2 and 3, because 2 and 3 added together don't give me 7. It will be 6 and 1. So 6 and 1 will give me 6 here, and 6 and 1 will give me 7 there. Okay, when I know this, okay, so when I know this, so I can write them in here. So 6 and 1 there, 6 and 1 there. What I do is I rewrite 7x as plus 6x plus 1x or x. Okay, so I'm going to rewrite this expression again. So we can have this is equal to 2x squared plus 6x plus 1x is just x, and then plus 3. Okay, So I've used the 6 here and I've used the 1 here. So I've rewritten this 7x as 6x plus x. Now what I do is I factorize these two parts here, and I factorize these parts, and I'll find that a common factor comes out. Okay, so if I factorize them separately, what I will have is 2x x plus 3, and you can already see that it looks a little bit like this one. So if I was to factorize a 1 here, I'm just going to write down plus 1 and then x plus 3. Now I can see that x plus 3 is a factor of this part here of my addition and this part here of my addition. Okay, so if x plus 3 is a factor of this part and it's a factor of this part, therefore I can say that x plus 3 is multiplying to 2x. So x plus 3 is multiplying to 2x, and I also have x plus 3 multiplying to a plus 1 here. Okay, so plus 1. Okay, so I've got x plus 3 multiplying to 2x and x plus 3 multiplying to the plus 1. So now I've factorized it. Okay, so the answer to this one here, I'm just going to rewrite it the other way. So 2x plus 1 and x plus 3. Okay, so I've factorized it. Again, I've got two linear factors for this one, so I've rewritten this expression as a multiplication. Okay, so it's a multiplication of this bracket and that bracket, and these are two linear factors for that. Okay, now the third one, let's do the third one, and we're going to use the same method for this one. So we're going to use the same method where we are going to multiply the a and the c. So this time 10 times negative 6. Okay, so I'll do that in a different color. So we have 10 times negative 6 gives me negative 60, and this is the number that I use to think about when I'm thinking about two numbers to multiply to give me this and adding together to give me negative 11. Okay, so I'm going to draw those boxes again. So two numbers, and remember these boxes are representing two different numbers. Could be the same number, but we're not going to say they're definitely the same. So two numbers multiplying to give me negative 60, and if I add these same two numbers, I should get negative 11. Now 60 has lots of factors, but I know 15 times 4 is one of them. Okay, and I can see that 15 and 4 can make 11. Which way round do they have to be? I have to have negative 15 and positive 4. That would add to give me negative 11, and I can say negative 15 times positive 4 here will give me negative 60. So I will have negative 15 and positive 4, negative 15 and positive 4. And what we do with these numbers is we now rewrite this part here as negative 15x add 4x, because that will give me negative 11x. Okay, so let's rewrite this. We've got 10x squared and take away 15x plus 4x and take away 6. Okay, so notice how I haven't really changed the expression, the value of it. It's still an equivalent expression. It's just that I've written take away 15x, add 4x, which makes taking away 11x. Okay, so again, we're going to be factorizing these two parts here and then these parts here separately. So let's do that. 5x is a common factor. 5x bracket 2x take away 3, and on this side I have 2 is a common factor, so 2 bracket 2x take away 3, and this time I have this thing adding to this thing, and both of these things have a factor of 2x take away 3. So I can say 2x take away 3 is being multiplied to 5x, and it's also being multiplied to a plus 2 here. Okay, so this then becomes 2x take away 3 and multiply it to a 5x and also multiply it to a 2. Okay, and we know this is how the distributive law works. Okay, we're just working backwards from that. So this is how we're going to factorize these. I just want to show you that if I was to reverse these, it would have worked. Okay, so if I was to reverse this, it would have worked. So I'm just going to start again from that stage there in a different color. Let's use red. So we've got 10x squared plus 4x take away 15x take away 6. So notice how plus 4x take away 15x gives me negative 11x. Okay, so I've just swapped these two around, and I'm going to try the same method and see if I get the same answer. So here 2x will factorize. Okay, so 2x, and then I have 5x plus 2, and from these I can say a negative 3 will factorize. Okay, so a negative 3. So I can say a negative 3 bracket 5x plus 2. Just check again. Negative 3 times 5x is negative 15x. Negative 3 times 2 is negative 6. So this is what this is working for us. So again, I've got this, take away this, and 5x plus 2 is a factor of both parts here. Okay, so I'm going to factorize that, and I'm going to have 5x plus 2, and I can see it's multiplying to 2x and it's multiplying to a negative 3, so I'm going to have 2x take away 3, which is the same thing we had here. Okay, just written the other way around. So again, what we've done is we've rewritten this expression here, 10x squared take away 11x take away 6 in factorized form, and we have two linear factors here, and this we can say is a multiplication. Some of the uses you can think about are we use factorization to help us solve when it's equal to 0. Also, when it's in factorized form, you can cancel down fractions, because when we're trying to cancel down fractions, we're looking for common factors for numerator and denominator, and this doesn't help us, but factorized form does. Okay, so these are some of the uses for factorization. Now here are some questions for you to practice. So factorize these expressions. Okay, what I'm going to show now is not going to be a proof of why our method works, but this should help you think about why it might work. Okay, so what I have here is two expressions. I've got A, B, C, and D here. Let's say they're representing integers, okay, like the 3, the negative 2, 4, and 5. I'm going to multiply them out, and then we'll try and think about why our method works. Okay, so this is going to be AC x squared. Okay, so this is AX times CX. AX times D is ADX, so plus ADX. B times CX is plus BCX, and the last one, B times D, is BD, so plus BD. And I'm going to do the same to this one. I'm going to have 12x squared. 3x times 5 is plus 15x. Negative 2 times 4x is take away 8x. And negative 2 times 5 is negative 10. Okay. Now, I'm going to simplify these middle terms. So plus 15 take away 8. That will give me. What's it going to give me? It's going to give me 7x in the middle. Okay. So this is going to be 12x squared plus 7x take away 10. Okay. And on this side, if I have a dx, remember a and d are integers, we said. Okay, so a d, the multiplication of two integers will be another integer. Okay, and bc is also an integer. Okay, so I can say I've got ad lots of x plus bc lots of x. Well, that's just like ad plus bc lots of x. Okay, so what I mean by that is I'll have ac x squared plus ad plus bc x plus bd. The other way you could have thought about this is if I was to factorize the x from these two middle terms, I will get ad plus bc. Just check, so x times that will give me adx, x times bc will give me bcx here. Okay, now for our method, we say that when we multiply the coefficient of x squared with the constant term here, Okay, that's something that we need to think about. Okay, so for on this side we're going to have, so let's do it in a different color. So we've got A, B, C, D. Okay, so that's the multiplication. AC times BD in this case. Okay, so this will give me a new number. That's the multiplication of all four of these integers that I had here. Okay, and again in this case it will be 3, the -2, the 4, and the 5. Okay, so here I had AC times BD. Here I've got 12. Remember, this 12 came because I had 3 times 4. So you can think of the 3 as the A and the 4 as the C. 3 times 4 is 12. Okay, and what I'm doing is I'm doing this coefficient of x squared times the constant here. So 12 times -10. That will give me -120. Now, what I'm going to think about is I can think of this as I can say that this is actually A times whatever the number BCD is. I can think of it like AB times CD. Okay, so AB will be a certain number, CD might be a different number. Okay, and I can think of the multiplication of that. But in this case, I had AC times BD. Okay, so AC times BD, but I just reordered them in a way. But I can see that this middle term here, this middle term is the addition of two things that if I was to multiply them, I get A, B, C, D. Okay, so this middle term here, I have A, D plus B, C. Okay, notice how if I multiply these numbers, I get A, B, C, D. Okay, so remember when we had our boxes, so I had a box times a box with a different number maybe, equaling the multiplication of this and that, and then I had the same numbers when I added them. They gave me the coefficient of the middle term. Okay, so here I've got AD and BC. Remember, AD and BC are two different numbers. So I've got AD and BC. Okay, and if I was to multiply AD and BC, so AD and BC, I do get A, B, C, D, and if I was to add them, I do get AD plus BC. Okay, what would this mean on this side? Okay, so what would it mean on this side? So on this side, we have this middle term here, the 7x. Remember, I simplified them already. So it's actually 15 add -8. Okay, so 15 add -8 is what I have. So I'm going to have 15 add -8. And remember, the 15, this 15 came from multiplying the 3 to this 5. Okay, and I had A times D, and that's what I had there. Okay, and the -8 came from -2 times 4, and on this side I've got B times C, and that's what I have there. Okay, so again I can see that these two numbers, okay, when I add them I will get my 7, and when I multiply them I will get -120. So let's just check that. So I would have my two boxes multiplying together, and then if I add them, this should give me 15 plus -8, which is 7. Okay, because we have numbers here, we can simplify it, and here we didn't know what the numbers were, so we couldn't simplify. So let's fill this in now. So we got 15 times -8. Okay, that does give me -120, and I also have 15 plus -8, and that gives me my 7. Okay, so this will give me my 7, and this will give me my -120. Okay, so maybe this is going to help you a little bit about how to think about why our method works. Okay, it's not a proof or anything, but it's just to help you think about or be convinced that, look, this method does actually work when we look at it in general terms like this.